All right, 6-4, Algebra 1, exponential growth and decay functions. So I have the explore and reason problem on to start off with. Cindy is buying a new car and wants to learn how the value of her car will change over time. Insurance actuaries predict the future value of cars using depreciation functions. One such function is applied to the car whose declining value is shown at the right. So years after purchase, 0 years, the value of the car is 20,000, meaning that when Cindy bought the car's value was $24,000. After 1 year of owning the car's value was only $19,440. After 2 years, it dropped down to $16,560. 3 years after owning the car, the value was $13,920. 4 years is $11,670. So, describe how the value of the car decreases from year to year. Well, it got lower. Like we could just say that it went. But yeah, I think ultimately they're just saying that as the years increase, the car's value decreases. I can spell decreases. There we go. What kind of function would you explain this type of pattern? Well, since we're not, like the value of the car is not decreasing at the same rate, like I'm not subtracting the same number year after year, because here it is, what is it? It's like a negative 560. And then we get into like 2000 and something that's beyond my comprehension on a Friday afternoon. And I can't find a calculator. Let's find out. 19,440 minus 16,560. 2,880. So, oh, that's not even 560. My bad. 24,000 minus 19,440 is 4,000. I can make that work. 4,560. So I don't even have to go on. Like those two numbers, not the same. So it's not linear. And the only other function that we've talked about at this point is exponential. So that's what I'm going to go with. Some kind of exponential function. And then what is the needed information or what is needed to find the function of the function the actuary is using? Well, we need to know the rate of, or the ratio, not the rate. The ratio of decreasing values, I guess. And we need to know the initial value of the card, if there is one. Okay, so ultimately, exponential equations, very, very general form. You have, it's an equation, I'm going to write it as a y, is equal to some starting amount. That is going to get multiplied by some sort of, I used it, we'll call this a multiplying pattern. And then, of course, that multiplying pattern has the exponent. So this multiplying pattern up until this particular lesson has been like, it's been given to you. Well, most of it's been given to you, or you've found it off of a table. Today, you're going to be told that things are going to like increase or decrease by a certain percent. So your pattern is going to change a little bit. So we can do something like a 1 plus or minus a percent. So how do we know what to use for the plus, or like which to use? Are we adding or subtracting? So you'll be told that you might have like a growth. And if the numbers need to be getting bigger, if your population is increasing, then you're growing, it's growing. And that would mean that you would take your percent given to you and add it. But of course, we don't do math with percents. It's just not mathematical. We have to take that percent and turn it into a decimal. So 1 plus the percent as a decimal. And when you do that, you should have something that is bigger than 1, which would make your starting value get bigger each time that you multiply. Okay, so for a growth function, we're going to add. That's the big thing. I shouldn't put that minus sign underneath it. Growth means adding, which would mean that if it's a decay function, or like we normally say it's an exponential decay, but like if your population is decreasing or declining, those are all decay. The numbers are getting smaller. Well, if we're starting at 1, because if we keep on multiplying by 1, the number is not going to change. And if we want the numbers to get, for growing, to get them bigger, we're adding a percent. So to make the numbers get smaller, we are going to subtract whatever that percent value is as a decimal, of course, because again, we can't math with percents. So decay or decreasing functions means we are going to subtract. So like if your school population is decreasing by 3%, you would go 1 minus 3 or 1 minus 0.3 because you have to take that 3% and turn it into a decimal. Okay. Cool. But that's just like things to keep in track of when we are writing these. So here we go. Example number 1. This population of Hillville is growing. So I'm going to just highlight that because that will tell me it's growing. I'm going to take 1 plus my percent at an annual rate of 15. That's awesome. I now know what percent I should add. So maybe I should change that. 1 plus 15%. Okay. The current population is 5,000. So this is my starting amount. And I want to know how much time it will be in 5 years. So that's going to be my exponent. The exponent is very much always time. Very, very much always time. So just to write the equation, I'm going to take my starting amount of 5,000 and then my pattern here of 1 plus 15%, but I have to change that. So 15% as a decimal is 0.15. And then it would be to the x, but I'm going to take that to the 5. Okay. So then from here, just to make my life a little bit easier, I'm going to do that addition. And then, so 5,000 times 1.15 raised to the 5th. And then the calculator comes out. So calculator, where can I put it? Can I make it shrink you down to size to fit on my screen? Okay. So I'm just going to go ahead and do the 1.15 raised to the 5th. So 1.15. And if I'm raising it to the 5th, I hit the XY button on this thing, and then notice, ooh, that's nice. It gives me the caret, which is what I would press on my calculators in my classroom. To the 5th equals. Okay, now I'm not going to write all of that, but I'm not going to clear it either. Like, I'm just going to keep that in my calculator and then click on my multiply by 5,000, because the calculator will store that number for a very brief amount of time. And then I don't have to round it. And it equals, what was it? It was 10,056.78, but we're talking about people, so we're just going to round to the nearest person, 10,057 people in 5 years, because story problem. And this is awesome because the other awesome thing, because there's a lot of awesome things about exponential functions. We're talking about estimated. So about, because there's no clear directions as to where to round. Do I round to the nearest 10 people? Do I round to the nearest 100 people? Do I round to the nearest 1,000 people? Like, those are all very different numbers. I chose to round to the nearest 1 person, which was why it was 57. So the about is very important. You can always argue with your teacher that you didn't tell me where to round in the directions. So, okay. Then we get into one of the most famous types of problems that we talk about in math when we talk about exponential functions, and specifically about exponential growth or exponential decay, is interest. There's a lot of interest formulas. So if you ever want to go into like finance, you will be like using this formula, although you'll probably using like Excel or Google Sheets or something, and you're not actually doing the math, but you have to know what these variables represent. So interest can be calculated in a couple different ways. In fact, there are 2. We have a simple interest. You can get interest simply, which means that the interest is paid only on the principal. That's what a lot of banks want to give you. They want to give you simple interest because it's cheaper for the bank to give you simple interest. Or we can have compounded interest. Now, compounded interest means that you get paid both on the principal, so the money that like you put into your bank account, and then also on the interest that has been given to you. So if you've put money into your bank account 10 years ago and you get interest every year, that interest, all 10 years of interest, will make the money that you have in your account even more. Like, each year you get more and more money. And that's what we're all about here. Okay, so then we have this gigantic formula. And I will tell you, there is a problem on your test that uses this formula. You will not have to memorize the formula. We give you the formula. We give you what all of the variables represent. But I'm going to talk about it. So the amount paid, this is like our Y. It could also be the amount, like it's your future amount, but it's still our Y. Like, again, if we talk about accounting and stuff, sometimes we think about it as the future, maybe the future value is how I've learned it. The principal amount, P, that's what you are starting with. This is your starting amount. See, it still goes back to that very general formula we talked about. It's your starting value. Here's your starting value. R is your interest rate. It will be given to you as a percent. You have to turn it into a decimal. Turn to decimal, which to do that, you would take your percent number and divide by 100. Close that parenthesis. Okay. N is the number of times per year that the interest is compounded. What that means is it tells you how many times in a single year you get paid interest. So, and it's the number of times. So there are some very, like if you get your interest compounded annually, then N is going to equal 1. I'm going to scroll to the right. N equals 1. Because you only get your interest one time every year. If you get paid or you get your interest semi-annually or maybe biannually, well, what did those prefixes mean? Semi or biannual sales happen twice a year. So semi-annual compounded happens twice a year. Quarterly means 4. There are 4 quarters. We talk about monthly as well. So how many months are there in a year? There are 12. And then the last one, even though I don't think we use it, I didn't see any questions in the homework problems. But I'm going to add it in the notes anyways. I'm going to stick it up over here. You could also get your interest daily, compounded daily. And if you do that, then that would mean that your N value is 365. I know leap years exist, which would mean that then there would be 366 days in that particular year. But for this formula specifically, if we talk about getting your interest daily, we are using a 365 for the N value. Okay, so those are the 5 main ones that we use for this formula. And then T represents time, which is typically going to be the X if we are like graphing the equation. So the time in years. How many years are you investing this money? Or how many years are you borrowing this money? Okay, so example number 2. Kimberly's family has invested in a certificate of deposit. Shown, all the information is shown lovingly in that picture. And we want to know what the value of the certificate of deposit is at the end of 5 years. So, boom, I know that my time value is 5. T equals 5. I know then when I look at this, my interest is compounded quarterly. So my N value is 4. I'm going up my list. My interest rate, R, is 8%, but I have to turn that into a decimal, so that's going to equal 0.08. And then my principal amount is $3,000. P is equal to $3,000. I 100% recommend that when you work with formulas like this, that is the first thing that you do. You identify what all of your variables represent. And then you can go through and plug the numbers in. Okay, so what was that formula again? I'll rewrite it. The future value A is equal to P times the parenthesis of 1 plus rate over the time. No, rate is over n. Raised to the n times t. Yeah. Okay, so now I'm going to put all of those numbers in. No, I'm not going to color code them though. So I have a 3,000 parenthesis 1 plus 0.08 divided by 4 raised to the 4 times 5. Okay. So from here, because I don't like making mistakes, I'm going to do the division of the 0.08 divided by 4. And I'm a bit risky, but I'm also going to do that multiplication because I can do that in my head. So as I rewrite this equation, all of that is equal to the future value. Like, yeah, I'm going to use the calculator to do the division here. 3,000. Okay, so I have 0.08 and I'm dividing it by 4. Are we okay if I also like add 1? I'm going to do that. So plus 1 is a 1.02, and all of that is getting raised to the exponent. 4 times 5 is 20, so my exponent is 20. Now, I think, like I know in the previous example, I like did things in bits and pieces, but you know what? We're using scientific calculators. They can handle orders of operation. So times 1.02 raised to the 20 is equal to 4,457. 57. I think it was like 0.82. So after 5 years, 84. Darn it. After 5 years, the $3,000 grew to be $4,457.84. Decent. Decent. It's an extra $1,400, almost $1,500. Okay, example 3. A video is labeled a fan favorite if it receives at least 1,000 views per day. Amelia posts a video that gets 8,192 views on the first day. This is our starting amount. Start. The number of views decreases by 25%. So 1 minus 0.25. That's my multiplying pattern each day after that. How many views will Amelia's video get after 7 days? After 8 days? I wonder when it will no longer be listed as a fan favorite. Let's find out. So my equation is my starting amount, 8,192, multiplied by 1 minus 0.25. We will do that subtraction raised to the x, but I know that x is going to be a 7 and then an 8 when I get there. All right, do the subtraction. 1 minus a quarter is 75 cents. 8,100. I'm not going to write the comma. I like it in my answers, but not when I'm showing my work. 0.75, Miss Hamilton, to the x. But I'm going to go ahead and stick my 7 in there. And again, calculator, 8192 times 0.75, raise it to the 7, equals 1,093.5. 1,093.5. So it is still a fan favorite. Speaking of fan favorites, please make sure that you like and subscribe. Just kidding. All right. After 8 days, all I'm going to do, my friends, is I'm going to change to the 7, 4, and 8. That's it. That's all. The equation is still going to be the same. So 8,192, 0.75 to the 8. 8,192 times 0.75, raising it to the 8, 820.125. 125. Not a fan favorite. So somewhere between day 7 and day 8, poor Amelia lost her fan favorite title. And we could find it if we wanted to use Desmos, but that's for example number 4, which, it is similar to a test question. What? I would never tell you that. Okay, Rich is comparing the cost of maintaining his car with depreciating value of the car. When will the cost and the value be the same? Oh, it's like a system of equations, except for like we're totally using exponential functions instead of linear functions. It's like we've done this stuff before. Kind of. All right, what am I doing? I want red, pink. So let's look at the value. Starts at 20,000. Let's put my y equals there because wouldn't want to do that. It decreases by 15%. So 1 minus 0.15. Ooh, I think that's a 0.85. Raised to the x because I don't know what it is. Then I have my maintenance function. If I can spell, how about I just call it the m function because I don't want to spell all of that. Y is equal to first year cost of maintenance is 500. That sounds like a starting value to me. And it's going to increase. So that's a 1 plus, what's my percent? 28. 0.28. That's nice. I like doing the increasing functions because I don't really have to math. Raised to the x. Okay. Then we get to use Desmos. So I have my 2 equations and I'm going to bring Desmos into, no, don't do that. Don't come back. Come back, Desmos. Okay, here we go. Desmos. Oops. All right. So go to desmos.com/calculator, type the functions on the left side of the screen, which would be here underneath the plus sign, and the arrows, which will either be your undo or your redo buttons. And we're going to do 1 per line. So I'm typing them in. Like I'm just using my keyboard. Y equals 20,000 parentheses 0.85, close the parenthesis. Okay, I lied. I'm not just using my keyboard. To get the exponent, I have to press the button. So again, all I did was I clicked the little keyboard option here to show the keyboard, the on-screen keyboard. But I want the button that looks like an exponent with any particular number that I could have. And I need an X. And then I'm just going to press enter on my keyboard and it advances to the next line. And I'm going to type in the maintenance function, y equals 500, parenthesis 1.28, close the parenthesis, get my exponent, and X. Okay, so I have my equations. And then step 3, we need to find the intersection of the two functions. And this is where it's going to be kind of iffy. So on the right-hand side, we have a little wrench, we have a plus, and we have a minus. I recommend the minus. And when I zoom out a little bit, I start to see lines. So maybe zoom out some more. And then we can also click and drag on the screen. So we're looking for where they cross. Somewhere. They cross somewhere in here, but I'm not seeing it. Now the red is on the left. Go away. Oh, there it is. Found it. Okay. So the reason I keep on clicking on the graph because I saw this little gray dot. The gray dot in Desmos it tells you like important things. This particular gray dot would tell us where the two lines intersect. And then this is kind of cool. So now I'm going to go to my wrench because I know it's 4,624. And like if I look at my x-axis, I'm going from negative 500 to positive 500. I don't need to be that zoomed, that squished on the x-axis. So let's just kind of make it a negative 10 to a positive 10. And then it's a whole lot easier to see that the lines actually cross. Okay, you could do the same thing with the y-axis and be like, well, I don't need to be a negative 3,000, whatever. Like, I don't need that. I could make it like a negative 2 or there, like a negative 2,000. And then you actually see the shape of the exponential graphs. So Desmos is a really fun tool. I definitely recommend that you kind of play around with it. But anyway, we needed to find where it intersects. So it intersects at that point 9. And again, I'm just going to round. So I'm going to say it's 9 and 4,624. Move that over to my other screen so that I can. So they intersect at the point 9, 4,624. Point whatever. Interpret your answer. Well, X represents the number of years and Y represents the cost. So in 9 years, the value of the car will equal the maintenance of the car. Maintenance costs at about, I'm not going to write that word this time, but I always like to say it in my head, $4,624. That is what it means to interpret your answer, is to state the number in a sentence, because that's what we expect of you. All right, exponential functions, exponential growth and decay functions specifically. And good luck, have fun, ask questions.